two, three, four right now. Okay, greetings to everyone that just joined. So let me wait just 2 more minutes. I'll start at 10 past 5 so we don't leave out if there's anyone that's planning to join. Okay. Okay, greetings. So today I'll be taking you through the industry expert session. Let me introduce myself briefly. So my name is Lindo Yende, but you can call me Lindo. So I'm a founder and a software engineer at LeadDevs. LeadDevs is a tech agency that specializes in building custom software for small to medium and large enterprises. So what are those like custom business needs? It's your websites, your mobile apps, e-commerce, and SaaS solutions. We also do data analytics. So Um, I'll be just not, I'm not going to be teaching you the basics of coding or how to program a full stack application. I'm not going to be doing that. But today we're going to be focusing more about what do we really do as full stack developers? How do you move from just knowing how to write code to becoming somebody that understands business requirements to understanding what do you do on an industry level? So let me go to the next slide. So what you learn, it's in either uni or in coding boot camps. You learn how to make crude functionalities. You learn how to like create, read, update, and delete. I believe that you are currently learning Manstack or you finished learning Manstack. So you know when you're doing Manstack, you learn about the get, the post, the put, the delete request, right? That's what you learn about. You learn about running things on localhost. You learn about JWT authentication, etc. However, that's not what you do every day in real world and real applications. For you to even create a real application, you need to understand what are you doing. So, what does the industry expect you to understand? So it expects you to understand scalability. We're going to talk briefly about all those concepts that I've listed here. So it wants you to understand scalability, number one. It wants you to understand security, the performance, version control, which is your Git and GitHub, CI/CD pipelines. You need to understand production monitoring. You need to understand that there are business deadlines. Before I continue, is my screen visible? Hello? Can somebody tell me if my screen is visible or not? Uh,
Yes, it is.
okay.
It's visible.
Okay, thank you. Okay, so please don't be afraid to open up those mics because it's hard for me to go in the chat and read messages in the chat. I had to stop, move from the screen and go to Teams. Okay. So, before we dive in deep into explaining what is scalability, what is security, how to understand business deadlines, etc., I'm just gonna ask you some question. And as I said before, I want interactivity, so don't be afraid to open your mic. Or if your mic is giving you problems, then I'll be looking at the chat for your input. So I want to ask today to say what scares you most about industry when somebody talks about real world applications, building real world applications, or rather getting employed in the real world. What scares you? Is it you feeling as if you're not good enough? Um, is it production bugs to say how do you fix now when large system crashes? Is it the interviews? And is it scaling systems? So I need you to maybe gonna say number one, number two. You can even elaborate. And yeah, so please answer me to say what scares you most about industry. Let me go to the chat to see if there are any messages here. Okay, I'll be waiting for your responses.
Okay, maybe I can start. For my case, I think what I fear most is not being good enough because it is my first time that I'm learning this. I know when I examine myself, I can tell the level that I am. So I feel that I need a lot of maybe time so that I can practice, understand all that I have learned. So as per the moment, if I'm told that I'm going to the field and work, my worry would be I am not being good enough.
Not being good enough. Okay. And then I see performance in the chat. So what do you mean by performance? Do you mean your application not running as expected, it being slow, or what? What do you mean exactly by performance? And thank you, Julius, for your response. I think everybody, even seasoned programmers, even people with 10 years of experience, they deal with them feeling as if they are not good enough. No? So let me see if there's anything on the chat. Is everyone okay? Okay, let me do this. So, not being good enough, it's not something that you can, I don't know, somebody cannot motivate you enough, and then you start feeling as if, okay, I can do this, I can be good enough. So, as I say, that everybody faces imposter syndrome, whether they are seasoned developers, whether they're starting out, imposter syndrome is there. But what do you need actually to like now step into the field without feeling any lack, without feeling as if you're not being good enough? I'll say building projects. So learning things in theory and practicing them are two different things. And in this field, in tech, you have to practice things in order for you to now say, I know Stack. In order for you to say, I know Java, I must have built applications in Java. And by building application, I must have sit down and wrote the code and not use like AI a lot. Of course, we can use AI to help us, but in order for you to now say, let's say you are a man stack developer, right? So in order for you to not feel an imposter syndrome, you must not allow AI to write your whole code base. Your front end is written by AI, the back end is written by AI. So what is your job? That's when you feel as if you're not doing good enough. That feeling of relying on AI or relying on tutorials. So now you lean on other things. You don't lean on yourself. You don't lean on your understanding. So in order for you to now not lean on AI, not lean on tutorials, YouTube tutorials, or whatever, you must sit down, take the time. If right now somebody can wake you up and say, how do I write a post request on a back end? You must think, what do I need to even start creating a back end? You must like these things have to come automatically in your head. It's not by magic, it's through learning. And then As I said, when you build projects, you build projects that must solve a certain problems or make your life easy. Let's say right now I'm in South Africa, right? If I was to build an application that I want to learn from. I want to learn my skills in coding. I also want to solve a certain problem that I'm not going to go on a tutorials. I can go on AI for feedback and guidance, but it's just a project that I'm solving a problem. So I can create a load shedding application. And when I create a load shedding application, you think to say, okay, before I even create anything, what what do I need to build this application? What is, remember, every application has its crude functionality. What am I creating? What am I going to be reading? What am I going to be updating? What am I going to be deleting? Are familiar with the term crude? I think you are familiar with the term crude if you're doing full stack development. So you first need to understand those things, right? So this is all talks about you thinking in like a systems thinking, right? So you're thinking in systems. Another thing is you must understand that most of the time as a developer, you're not just going to be writing code for yourself or code that's used by you. You're going to be working oftentimes in teams. So right now, since you're in school, utilize the time with your peers. Have some peer programming session. This builds collaboration within the group. And as you are able to communicate your ideas, as you are able to communicate with each other, this is how you build team collaboration, which is the key in companies. Whatever company you go to, they want to know, are you a team player? So there are a lot of things that can make you feel as if you're not good enough in tech, and this is just one of them. Being a team player, working well with other people, and also in the sense of collaboration. If one of you, maybe you are given a project, a certain project, if one of you has a bug, make it a mission that you as a person, as an individual, you try and find ways to assist that person, because in you finding ways to assist another person and solving their bugs, you're also learning something. Number one, you're learning something that you'll never forget because you took the time. You maybe you called them on Discord or you called them on WhatsApp and you had this one-on-one interaction. So you're never gonna forget that time. You're never gonna forget the solution. If you were to come across the same bug again, you're not gonna forget it. And then what else did I wanna say? Um, and the issue of not being good enough, it's learning, doing projects, and also freelancing. What do I mean by freelancing is asking somebody, let's say you know a small business owner. Even if you don't know a small business owner, you have a cousin, a sister or brother that has maybe a small shop, or maybe they do a hair braiding business. You can do a website just to showcase their skill. And then this all looks nice in your portfolio in a sense that you can now say, this is my freelance work. I've worked with businesses, I've worked with hair salon business, I've worked with shop businesses, I've worked with funeral service. Like you can now build a portfolio to say that I've not just like built a calculator app, I've not just built a weather app. All of these things are there on YouTube, they're there on Google, wherever you, everybody has the same portfolio. So you being unique also builds that sense of worth to say, okay, I've done this, I've built this website, and nobody can build it more than me. So I believe this is how you move from feeling as if you're not good enough to now thinking that, okay, I'm somewhat an expert. And of course, you must also know that once you know one or two or three things, you don't necessarily know above everything. Tech is forever changing. There's always something new every day. Your normal technologies right now, the express version gets updated tomorrow. What was relevant yesterday, what was relevant in your code today is not going to be relevant tomorrow, and you have to continuously adapt. So, in order for you to build that adapting mindset, is to be willing to learn, willing to change how you think, willing to adapt. Let's say right now I was to move you and say, okay, I have a job that requires you to be a Python developer, but you know Manstack. So you must not feel as if, okay, I cannot do this because I only know JavaScript and things that are pertaining to JavaScript. Because believe me, this is the same thing. It's just going to be a different syntax, a different way of laying things out, but it's still the same things that you're familiar with. Even if you're writing code in Python, you're writing it in Java. You're still going to be using the same MVC structure. You're still going to be working with post request, delete request. You're still going to be working with those CRUD functionality, actually. So there is confidence from knowledge, and then there's confidence from experience. So in order for you to now build the confidence in this field, you need to continuously be building, continuously learning, and engaging with others, actually. It is as simple as that. So let me go to the chat and see if there are any messages. Okay, there's nothing. Okay, let me move on to the next slide. So I don't want to be talking alone and feel as if I'm preaching or it's a sermon. So please feel free to drop messages in the chat and I'll answer if you want to talk. While I'm talking, you can send a message and then I'll look at it and I'll give you permission to talk. Okay, then there are production bugs. So think of it like this. Let's say you get hired today. You are a software developer at this big company or even a small startup. And now your application is not running. So, how do you fix it? Let's say you're trying to now run the application. Maybe you're saying npm run dev or whatever that you say to start it up, and it's not running. Or let's say now the code has been deployed into production and suddenly it stops, or before it's even in production, but there are bugs everywhere. And I think you have seen so far in your learning experience that applications don't work as you expect, right? What's this? The compile time errors and the runtime errors, and there are different ways to solve the two. But we're not going to be talking about that. We're not going to be in technical terms. We are going to be talking to now understand our approach to solving like the production bugs, in order for you not to feel intimidated now when the time comes. You don't want to be feeling as if, okay, how do I even approach this? Because now this is a real system. So, in a real system, when you're building real systems, you are having real users, you're dealing with real data, you're dealing with real consequences. So, what I mean by consequences, when your application is running, when your application is having errors, or when your application has vulnerabilities, the company is going to suffer. The company is going to suffer from the downtime. It's not going to be making money once the application is down. Or if there are vulnerabilities, anybody can simply come and take data, or they can come and manipulate the app or whatever. So you need to understand that, okay, when your code fails in production, this is what it's at stake. Not to make you afraid or make you fearful or to intimidate you, but it's to introduce you to a different way of thinking, which is to say, if this system crashes or if this does not run as expected, what is my backup plan? And if now this fails, what implementation can I do to solve it? It also brings us to this thing of writing tests. In an application, whether you're just writing a back end application or front end, you must have unit tests. Unit tests are the key to a working application. Not to say that your application won't fail or crash, but writing those unit tests is going to save you a lot. Whether you change things in the future or not, but having those unit tests in place are going to save you. So we have the production thinking framework. So the production thinking framework, it says before deploying code, ask, what happens if this fails? How will I detect it? How fast can I fix it? What data could be corrupted? Let's say right now you're working for a bank. Let's say you're working for F&B, and then you write code that has vulnerabilities. Let's say you write code. Um, when your code there is you try implement like JWT authentication. However, there's still some vulnerabilities there. What do you fix? Like, how do you make sure that this is secure enough? Or like trying to think to say, if somebody was to get into the site, if this is not secure enough, what is at stake? What can be lost? If this is a big bank, money can be lost. Number one, trust. The clients are not going to trust the bank as before. You, as a developer, you're not going to be trusted by the bank or anybody to hire you. So, this is this now introduce you to things to say in production when the slow check the system is slow, the slow loading, slow checkout, there's a loss of revenue in business. When the API is down, the client is angry, and by client I mean anybody that's consuming the front end. When there's a memory leak, the server crashes. Okay. Let me go back again to say, okay, so we talked about not being good enough, talked about production bugs. So interview scaling system. Okay, I'm not gonna talk about interviews for now. I'm just gonna talk about scaling system. Oftentimes you hear about scaling systems. You hear about building scalable solution. I believe every tech agency or every company that's in consulting that is working with software, what they do say is that they build scalable solutions. What does this term scaling really mean? So, oftentimes people think that when you talk about scaling, you're talking about that the application you can add more features to the application, which is not true. So, scaling means that this software that I built can survive the growth. If this software today has 100 users, and if tomorrow it has 100,000 users, it won't change anything. That's what scalability means. You say if this system is used by 50,000 people, they can all use the same system at the same time without it crashing. And I'm just gonna talk about like small, like technical terms to say how do we ensure that our system survives the growth, survives the changing users. So number one, we have concepts like rate limiting. So rate limiting is when, okay, said I don't want to talk about technical terms, but rate limiting is when you build, let's say you build your API and then you make sure that whoever that is logged in as a particular, let's say the user 10 is logged in, and user 10 can only access this certain API, can only maybe like do a get request for maybe 5 times. Let me say that they can only do like get request to this API 5 times, and if they try to do it more than then the system is going to tell them that okay, no, you can't, because you have to wait maybe about like 10 seconds in order for you to access this API again. Or if somebody's trying to log in and they try logging in maybe multiple times, then the system is going to tell them to say, okay, right now you've reached like your limit. Then it maybe loads and waits for 10 minutes, I mean 10 seconds. Usually it's not like minutes, maybe like a couple of seconds, 30 seconds to 10 seconds. It's all dependent on the person creating the system and how big it is. And then what else that makes the system scalable? I'm gonna say load balancing. So I'm not sure if you're familiar with load balancing. So don't want this to be a technical session. Just gonna move on from that. So it's rate limiting and load balancing. It's what makes system scale in a way. So we're gonna talk about like different scaling. You have user scaling, you have data scaling, and then you have feature scaling. So right now, what we're talking about with um, if your system today has 100 users and if it has 100,000 users today, can it survive that? So if I have more users, what breaks? The database log, the CPU usage, the network latency. So in building applications, you must think about all of those things. And remember, um, we are storing our users somewhere, right? It's either you're using maybe PostgreSQL or you're using MongoDB. And your level in your application, the level of the application, can it take a 10,000 users? You know, when you go to MongoDB Atlas, you can select how many users you're gonna have, or I'm not sure, does MongoDB have a pay as you go? Because some databases have a pay as you go. As you add more users, it also charges you more. And then we have data scaling. So data scaling is also this almost the same as what I just talked about to say If now I have large database, and in a database, I obviously want to find something from it. So what does it mean now if I have a large database? It means the query performance is going to be compromised. And now, how do I fix the query performance? You need to think about that. You need to think about indexing and storage, as what I just mentioned right now in the MongoDB example. And then we have the feature scaling. So what is feature scaling mean? So feature scaling is, when you build an application, it has a primary goal that it solves, like a primary solution, right? And then now there might be like more complexity that are added. Let's say, let me think of an application. Let's say a cell phone, right? Let's say in a cell phone, the primary goal is to make calls, right? And it's you calling and receiving calls. And then now adding more complexity, when you add more complexity, like now messaging, what breaks? What is gonna break? Is it gonna break? Is it gonna affect the primary goal, which is calling, or is it going to be different from each other? So you need to think about all of those things to say how do you maintain it, the team velocity, and the code readability. Code readability is one essential thing also. I'm going to talk about that in much more details, but just want to highlight to say in order for you to write code that can be, remember, if you're working in large companies, or not even large companies, but in a company where you have a team, other team members, can another team member read your code if they were going to take over? Can they read your code? Can they understand why you wrote this function? Can they understand what this function is trying to say? And how can you do that? It's by you writing a clear definition, like a clear naming your variables clearly, naming your functions clearly, naming your classes clearly, and yeah, comments here and there, but comments are not really like necessary part of things, because as software developers we know how to read code, but comments, they are not a make or break thing, but they're also essential. And then also in the part of maintainability, remember I gave an example about now to say if there's a cell phone, the primary goal is to make calls and receive calls. And when I add a new feature such as messaging now, is it not going to interfere with the normal usage of the cell phone? It is based on how you structured your application. So you must also know how to be an architecture, how to architecture your system to be independent. So we have monolithic architectures, and we have like microservices. So they all differ in terms of what are you building, and how do you want your system to communicate? Okay, okay. Before we move on, um, let me see if there's anything on the chat. My screen is loading. When is this message sent? Okay, is it fine now? Can somebody answer me? Is my screen fine now, or has it been loading this whole time? It's okay. Okay, thank you. Okay, I've said a mouthful, and before I ask, I want to ask also what do you think is hard in real life. But before we do that, I want us to have a short case study. Okay, I want us to go through this short case study. So, in this case study, I'm just gonna ask you, what do you think? I'm also gonna give you time to think about it. I'm not gonna expect an answer from your feet, like straight out of the, your mind, just like that. So, the case study is that you are hired to build a food delivery platform, right? So, a food delivery platform. The food delivery platform, it's an ordering system, in a sense that it can be used by customers to order their food online. And once they order their food online, the food is processed and delivered. But it's not only used by customers, remember. The person who's going to be delivering the food also needs access to the application. So it's the customer, it's the delivery people, and also the people working at restaurants. We're going to say the restaurant staff, gonna say restaurant managers. So we have all this different level of users, right? And now, okay, the role is simple. Customers are just gonna be able to order their food online using their smartphone for either to get the food delivered to their houses or they can collect the food in the restaurant. So I'm not sure how much time can I give you. Let me do this. I'm gonna give you about 10 minutes. Is that okay with everybody? And then I'm going to give you 10 minutes. Then in those 10 minutes, you can think to say, what do you need? What are you going to do? So in my screen here, I want you to think, what features are you going to build first? How are you going to structure your back end? What would break at 10,000 users? What security concerns exist? So I want you to think about all of those things based on what I explained to you about scalability. So, in you using what I just said about scalability, I need you to also think to say, okay, if I was building an application right now, a food delivery platform, what am I building first? Why does it matter? What are the key things that I need to have? What will I be using? And then what programming language are you going to use and why are you going to use it? Because let's say you are a Python developer. There are times when you don't want to use Python. There are times when you want to use Java because Java has Spring Framework and Spring Framework is much more flexible and it gives you so much built-in features. So all the times when I want to use Python because Python has maybe like data analytics. It allows me to have like use Matplotlib. So there are different times that require you to use like different languages. You just need to know and understand why am I using this programming language in the first place. You can also make it work using JavaScript, but it's not going to be the same as it was maybe using let's say C. So please, I'm expecting feedback from you. I'm gonna give you 10 minutes, so we're already at 9 minutes right now. So please keep those responses coming. 1, 2, 3, 4, 5. Please keep the responses coming. It's either you can open your mic or you can type something in the chats. But I'll be happy if you open your mic because right now it sounds as if I'm preaching, and I don't want that. So yeah, I'm gonna give you time. Okay, thank you so much, Tabiso, for your response. So, Tabiso says he'll start with authentication, followed by the menu, select items, add and delete, navigation, di- navigation, different screens. Okay, I'm not sure I follow by navigation, different screens. I'm not sure that I follow what that means. Are you saying like different screens for the customer, the
No, no, I mean, as first features, you should be able to navigate on different screens. If you want to go to the menu, if you want to, if you have a different screen for, let's say, if it's if you want to see sides, drinks only, things like that, you should be able to navigate between those type of screens.
okay, okay, okay. Thank you so much, and I understand now. Okay, what is everyone saying? What do they think? There's no wrong way of thinking. Like, what is your thought process saying? How do you turn something so complex to now small buildable features? Like, where do you start? Okay, I thought I saw Julius typing. I'm not sure what happened. He stopped typing. And then is everyone else completely clueless on how to move on forward? Okay, thank you, Julius. He says that for the back end, I'll start with models, that is users, orders, etc. Then go to controllers where I would have the logics like create, get, etc. Okay. Then go to the middleware for authentication and also role control. That is very important. Then routes and finally server where I would mount the API for the front end. I will start with the login, then fetching the API. Brilliant. Okay, this is brilliant, brilliant, brilliant. I like that you've given me like a description to say this is where you're gonna start and go. I like that. I like that. Now it's four of you, and then where are the other two? Are they with us in the session? Okay, you're clueless. Okay, there's no problem. Absolutely no problem. So, sometimes you obviously don't know to say, okay, I'm gonna go and create models like this and controllers. This is what I'm gonna write in details. However, even when a client comes to you, I got the because the only one I know, okay, 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 thank you. So oftentimes, even I am in consulting, right? So even when a client comes, they themselves sometimes don't know what they want. So you can not go there and write controllers before you understand what exactly do they have in mind. Because they have like it's just a small idea. They'll tell you that I want a food delivery system, and you are the one that's gonna now have to think to say that, okay, who's gonna be using the food delivery system? Just be able to probe further to say, okay, who's gonna be using the system? It's users who order their food. It's gonna be the people that's gonna be delivering the food. It's gonna be hotel staff that are gonna be processing the order and handing the order to the delivery person. Now, so now you understand that okay, there's not gonna be different role-based access, right? Which is what Julius said. And now to a client, you must also not try to sound technical. You must try and explain things in terms that they'll also understand. And also to business stakeholders, business stakeholders don't understand what you mean when you talk about role-based access. What they going to understand from you is when you say that everybody's gonna have like maybe different access level. um, the user can only access this, the admin can access this, the moderator, who's going to be a restaurant staff, can only access this. So you try and paint a picture, number one, for a non-technical crowd. And now you can now start to now implement a design. When you design, you do an architecture. In doing an architecture, let me go back to my slides. When you design an architecture, you now need to think about what is necessary. What models do I need to have? So before you can even, you can do a front end, you can start with the front end or a back end. It all depends on you, but I will choose to start with the back end because I mean that's where the job gets done. That's the now that's the brain of the whole application, the backend. So I need to know what models do I need. Let's say I create a model for users. What does the user take? It's going to take maybe the username, it's going to take the email, it's going to take maybe the password because they're going to be logging in here, obviously. Okay, what besides the password, what else do I want to know about the user? The address, you know? Now you've structured the user model, you're going to structure the driver, the person's going to be delivering the food, the driver. So you're going to structure their model. They are also a user, but a different user. There's going to be an admin. So what is different from all these users? You think. So there's a customer, there's a delivery guy, there's a restaurant staff. You need to think about all of those things. Okay, cool. You've thought about them. Now, in every application, there's going to be crude functionality. Now, you need to think, what are we creating? What are we reading? What are going to be updating? What are we going to be deleting? We are going to be creating menu items. In order for a person to start ordering or doing anything, they must see a menu first. So I'm going to create a menu. And who gets to update the menu? Number one. Who gets to read the menu? Who gets to delete an item from the menu? Now, this is when you think about, okay, there's going to be an like a restaurant manager who's going to be an admin according to my system. And as an admin, they can update the menu. And the menu, they can update the pricing, number one. If they want to change the pricing, if they want to delete the dish, maybe we no longer say that in the store, they don't sell this anymore. They have the permissions to delete this. Okay, cool. Let's think. Let's now say, okay, we have now the menu. We want the customers to be able to see the menu. So they can only read the menu, but they can't update the menu. They can't delete the menu. You understand? So now this is how you implement the role-based access. Okay, cool. And then you also need to think, okay, besides now them being able to read the menu, what do? They can choose items from the menu, they select, they go to the checkout. In the checkout, what do? They need a payment integration system. A payment integration system can either be using PayPal, can be using credit card, can be using cash on delivery. Now you need to plan for those things in your application. Now this is when you think to say, how would I structure my backend? You can obviously use JavaScript for this. You can use JavaScript to build this backend system. You can use maybe React for the front end. It's okay. Now, what would break if this application was to have about 10,000 users that are logged in at the same time? How do I handle it? Now, this is where we talk about like load balancing. Okay, then what security concerns exist? Julius mentioned that, was it Julius or Tabiso, that he will start with authentication because authentication is going to be the key part of this thing. Because as we said, we're going to implement role-based access. In order for us to implement role-based access, we must have authentication. Then upon authentication, this is when the system can check what what role or what permissions are you authorized to have. Okay, now let's go to the slide. Let me open this in full screen. So, I think I've talked about this. The approach. The approach is asking the right questions first. You probe the person that's asked you to design this. You probe them to say, what more do you want? Obviously there's going to be something that checks where the driver is, right? So what is it gonna how is it gonna be doing that? So you need to ask the person that's asked you to do this like the right questions, and then you need to ask yourself questions also to say, okay, how do I build this? How do I integrate the maps into now this system, and how do I implement the system tracking? So now you understand that now there's going to be another controller that you write that's going to be dealing with tracking the driver, tracking the food, where is it right now, what location is it on, is it in rather. So you have like to build a lot of things. So if I was to build this, I believe that I was going to use a microservices architecture. I was going to use a microservices architecture to make this. I'm not sure if you're familiar with the microservice architecture, but I was going to use it. I was going to use Spring Boot. And then what I was going to do is that I was going to build a tracking system and make it an embedded, and then I'm going to build a payment integration and make it an independent system. Then I'm going to build a menu and a food ordering system and make it independent. But all these three systems are going to be talking to each other. And then there's going to be a service that's going to be an authentication service where you're going to create your users, update your users. So now all of these things have to first start at the authentication service. And then after you have been authenticated, you can now access all these different things. Okay, cool. Okay, so the second point is that software engineering sometimes mean you have to be a consultant. And then you need to understand the business requirements in detail. You can't execute something you don't understand in details. So oftentimes you find yourself that you're going to be doing the diag. You see this picture here that I'm circling right around this architectural diagrams. You need to be able to build these things, right? AI can't do it for you. You need to build these things and understand them, communicate with your teammates, and understand the approach. Understand this is understanding the flow of the application. What talks to what? If I build an odd controller, how is it going to talk to the ordering controller? How is it going to talk to the payment controller? So you need to do an architectural diagram to explain all of those things. Then you can go there after then and build a front end. In the front end, you also need to communicate with the client to say what colors and themes do they want, but that is secondary. The primary concerns are understanding like the business requirements. Then the secondary level is understanding maybe the UI and the UX. What is the company theme? What logos do they have in place? They are given logos. Do they correspond with um, the site, like the colors of the site they want? Okay, if they've told you the colors, how do you implement them? So now this is UI and UX. Okay, cool. You've done your UI and UX. Now you need to fetch. Remember, you have a backend that in place. Now you need to fetch the API on the front end, right? So are you using Exos or using Fetch? Depends on you. Okay. And then in terms of like choosing the tech stack, that sometimes depends on the company that you're working for and their preferences. A lot of companies like .NET and what's this Java and C. So, or you can also like choose a tech stack based on the requirements that they've told you, and then you can choose an approach that's going to be scalable. As I say, that my personal choice was going to be Spring Boot Java because it has like a lot of built-in features, and I can build microservices using Eureka, and then the services are going to communicate with each other because this is a large system. And obviously, as a large system, you can build it alone, but oftentimes you're not going to be building alone. And if you're not building alone, maybe somebody can build that part of like the tracking part of things. Another person can be building the payment ordering, the payment system. The other one's going to be building the ordering system now, where you select the menu, you create the menu, etc. When another one's going to be building the authentication part of things. So all these things can be built simultaneously by different people, and they communicate with each other using things like OpenFaith. So it's all dependent on you and the company. You can also do this again with the man stack. You can do this with JavaScript on the back end. It's just you just need to now do a lot of heavy lifting. Okay. Okay. So now things that you need to know is you need to know how to structure code in real projects. And another key part about being a software engineer is writing documentation. There's technical documentation and there's non-technical documentation. So the technical documentations are going to be your README Markdown files. So the README Markdown files are going to be directed to another software developer or your system analyst or whatever that whoever that is technical. And this is going to be making them understand how maybe like how do I run this application. Uh, Technical documents. I'm going to show you an example just now. And then following the best practices, environmental variables, logging, error handling, authentication flow, rate limiting, and git flow. Okay, before this, let's go back to the second question that I had for you. Not sure where it is. Yeah, here it is. So I wanted to find out to say, what do you think is harder in real life? Do you think it's writing the code? Or is it understanding the requirements? Or is it debugging? Or dealing with clients? So clients are the people who are gonna ask you to build a software. Most of the time, like tech agency deal with clients to build solutions for them, like help their businesses with custom software and everything. So what do you think is hard? Is it like writing the code, understanding the requirements, debugging, or dealing with clients? So again, you can answer the question in the chat, or you can open your mic and tell me what you think. Okay, I already have an answer. Debugging. Okay, dealing with clients. Yeah. Okay, the other two was Julius, and is Steve here with us? I haven't seen him interact with us in the chat. Dealing with clients. Okay, I think it's dealing with clients. Okay, yeah. Okay, yeah, this can be quite intimidating dealing with clients. However, in some companies, they have a system analyst or a business analyst, which are the ones that communicate to client and they get the business requirements and they make them technical requirements and they hand over the technical requirements to you. But in other companies that I know, the software engineers themselves, they talk to the they talk to the clients and they gather the requirements themselves. So it all depends on how big the company is, the budget of the company, etc. And then, yeah, dealing with the requirements is hard because, I mean, dealing with clients is hard because it's not something that you can learn in a book or watching a tutorial, but it's like a soft skill. It's how you communicate. It's how you communicate. So I remember also there was a time when an elderly woman, like specifically. So you understand when I say like elderly. So she was about 60 and above. So what they wanted is they want a goal like they have a golf fundraiser event, right? And for the golf fundraiser event, they want to have a site. In this site, what they want, like the primary goal of the site is to for people to see what balls are available, like what balls are available. So this like fundraiser comes with dinner also. So if they just want dinner, they're gonna say they want dinner. And if they want like 4 ball, they're gonna say they want 4 ball. If they want 8 ball, they're gonna say they want 8 ball. So the users have to select, and after they select, they're gonna get an invoice, and then this invoice has to be sent via an email. Okay, cool. Then they're gonna pay using the invoice. So now, because this person does not obviously understand like what needs to be done in terms of like technical jargon or what they want, they don't have a clue to say, okay, this is how I want the structure to be. I'm the one that must now say, okay, I'm gonna make a site that's gonna now um, have a selection method. From the selection method, it must be able to generate an invoice. And what am I going to use to generate the invoice? What am I going to use to send an invoice? But prior to that, I needed to draft like a document, and this document I have to now get up and think about the requirements. She told me what she wanted. She didn't tell me like the business requirements in paper. She just told me by mouth, and I now have to gather the requirements in writing so that we can both agree. Because she's not building this for herself. Obviously, she has a committee, and now she has to take this to the committee. So there's gonna be like a lot of communication in place. And as I said, those are not young people, so things that like feel easy to explain to somebody young is not gonna. And besides them being young or old, it's a matter of also like they don't understand those technical terms. So I have to make this something simple. It's like they don't need to know how the system works. They just need to tell me what do they want. So now, okay, I asked for the designs, obviously like the colors and everything. But the primary goal now, I need to get like in detail to say, okay, after generating the invoice, how do they pay? Do they pay? Do they do like an EFT? Do I add the payment details in the invoice? Do they, what do they do? Is there like a payment integration of the application itself? Is there an authentication in place? What do I do now? Right? So I needed to get all of the requirements well. And the projects got paused for a while because there was not like a clear understanding between me and my team and them in terms of like communicating exactly what they want. Then they sent us like a site which it was like an Oratambo golf fundraiser event. So they sent us like an example of like okay, they want something similar. However, when we were communicating with them, I feel as if like we were overwhelming them because we're explaining things in like technical terms. We're explaining that we're going to be using a recent API to now send the invoice via email. So they don't need to know all of those things because this makes the client overwhelmed and lose trust in you. So you make them you just try to communicate to say, okay, is this what you have in mind? Is this a picture? Then you keep the technical terms to yourself. You keep the technical implementations of how you're going to implement this with your team. But when you're with them, you just discuss the things that are on the surface level, what they're going to see, the colors, the themes, what does now the football have that the eight ball doesn't have? What does the prize dinner have? Now you start like talking with them in the non-technical way that they understand. And in other companies, you find that okay, you are not dealing with clients per se, but they are business like stakeholders. So business stakeholders, let's say you're also working in let's say you're working in a company again, let's say a bank itself has business stakeholders. So let's say you're going to be building a app for the bank, an app where users, the bank customers can now log into their system, check their balances, etc. So now let's say they ask you to now add an AI integration, add an AI chatbot into that banking app. So now you need to communicate with them in ways that they understand non-technical terms. So they speak in non-technical terms, and you and your team are going to communicate in technical terms. They don't need to know about code functionality. They don't need to know about the get request, the post request. They just need to know that the application is going to be working and running as expected. Okay. And then Tabby. So think as a Tabby. So that's said. No, it's FB. That's said. Debugging. Okay. So y'all don't feel intimidated about writing code in real world application. Okay, because I think this is also like one challenging part about like in real world projects. Writing the code itself is also challenging. But okay, so it's debugging and dealing with clients. Debugging is the same, actually. It's the same because and however big the application is, you need to divide it into chunks. Remember the example that I've given you. not all the food delivery system. The food delivery system has a part of authentication, it has a part of payment, it has a part of order tracking, it has a part of like menus, menu selection, etc. So you take each part of the application as it is, you write it as like one component, and then you're gonna focus on now how do they communicate. Now, in terms of debugging, what key thing it is in like debugging is understanding like the error trace that you get there. Understanding like the stack trace, the error trace, if you are getting like the error in the console log, or maybe you're not testing an API and you get like a 403. What does a 403 mean? Okay, you understand like that a 403 means that okay, like this is not it's not found, right? There's like status 500. So you need to understand like status code, right? There's like 200. The 200 status, like when I say 200, I mean 200, 201, 202, 203. So this means like one thing. When something is okay or accepted, there's a 201. When it's a 404, it means it's not found, um, not authorized, no authentication, etc. 500, it means bad request, right? I mean, there's something wrong in your URL or something. So that's like the key part of debugging. Whatever application you're in, it's understanding the HTTP request, number one. Number two, it's understanding the error in the what's this, the console log, right? So let's say right now I was to get an application, and then my application I get a forbidden, a 403 forbidden, maybe for example. If I forget a forbidden, it tells me that this person is not authenticated. Or if they're authenticated, it means they are a user and they don't have the permissions of an admin to access this. So this is debugging becomes easier in that way, okay? Not easier, but it becomes more approachable because whatever that you're building, whether you're building a simple calculator application or you're building a banking app, there's still going to be debugging and understanding that, and not just copying the error and sending it to AI. It's better for you to learn how to approach the error. How do you approach the stack trace? How do you approach the status codes? And then not saying don't use AI for debugging. You can use AI for debugging, but make sure that you understand the solutions it is giving you. And if you were to face the same problem this other time, can you solve the problem without taking the problem to AI again for the same issue? You can't get a you can't get a 500 status code today and then AI helps you solve it. Then tomorrow you get the same error and then you gonna ask AI to help you solve it again. This means you're not learning anything. So AI should be also used as a companion to help you now upgrade, better yourself in this tech field, in this tech game. What else did I want to say? Okay, I forgot. But yeah, I'm gonna come back to it. Okay, so let's start with writing code. How do I write code now in production, or how to write code for a real system? Number one, you must write code that works. Obviously, that's like the key part. You must be able to write the code that scales. We've been talking about scalability, etc. You must be able to write code that scales. You must be able to write code that survives team. Okay, so what does clean code mean? Clean code means clear naming your variables, your function, your classes clearly. Okay, sorry. Okay, my battery. Okay, so it means naming your variables and functions clearly, separation of concerns. So remember when you talk about separation of concerns, I think I forgot to talk about this, but this is one key part, and I think it's something other people do, and I don't know why. But if you are creating maybe a controller, your controller has to be a controller for authorization, just authorization. And if you create a controller for the payment integration, it must be just about that. And if you can create a controller for now menu, creating the menu, updating the, it should just talk about that. It should just be for that. And I think if you go back to the solid principles also does tell us that to say the S in the solid principles, it says the S stands for single responsibility room. Even when you create models, don't create a model for the user, model for the payment, all in one, you know, and it makes things unreadable, number one. Number two, it makes things not maintainable. So separate things. Okay, modular functions, no duplication, readable logic. Okay, so all those things like make readable logic, use structuring, your naming your files well also. So I'm not sure who it was who told me that they were going to be start by creating models and controllers after. So when you do that, name your models in a way that you create a folder for your models, you create a folder for your controllers, you create a folder for your views, you create a controller for your services. I mean, you create a folder um, for everything. And then from that folder, you name the files accordingly to what it's doing. If in my model folder, if I have a user model, I name this a user. I'm gonna say user.js. Then if I have a model for menu, I'm gonna name this as menu.js. So follow the proper naming conventions so that your application is readable. Anybody can see to say, okay, this is how this is like. So now, bad code, when you write bad code, you are now gonna make debugging hard for you. When you wanna find where the error is coming from, you can't even find it because you don't know where your model is. You labeled your model in a wrong way or whatever, but it makes debugging hard and it takes a lot of time to debug. And then in order for it makes also like onboarding time hard or increases like onboarding time, feature development time. So all these things increase when your code is bad. So if you're gonna add something new into your application, how are you gonna add it now when your application is not making sense? There's a lot of lack of clarity in your application. Let me plug in my PC before it gets low and then it shuts down. Um, okay. Okay, so we've talked about writing code, and then here's this part. Technical debt, it is future engineering takes. So if you write your code and hope that, okay, if this works, there's like a lot of like misconception that if something works, don't change it. People end up writing bad code and trying to get things work without following like clean code steps. So they're just trying to get things to work without following like the proper procedures, without following the proper naming conventions, etc. So that's gonna cost you later in the future when you want to now build something, you wanna add new features or you wanna debug, etc. So this is what we mean by future engineering takes. Okay, cool. And then still in the topic of, let me do a full screen. Still in the topic of writing code. So how do you build code that survives teams? If you were to leave the company tomorrow, can somebody maintain your code? Not even you leaving a company. If you are moved from this project, can somebody read your code? So there are things like Swagger. I'm not sure if you're familiar with Swagger, but Swagger, I'm not sure what to call it, but yeah, you add it as a dependency. If maybe you're using Express, you're gonna say npm I Swagger, or I'm not sure if what is it called in Express? Is it npmi swagger? But in Java, you can add this as a dependency on the POM XML file. And when you add it as a dependency, um, you know how you add things as a dependency in your package.json file in Express, right? Then after it's now added as a dependency, you can now start using it. You can either use it now by importing it. You import things in your Express, and then um, in this case, what you're going to do is now you're going to just add add Swagger, and then Swagger is going to now do the documentation for you. It's gonna say, okay, this is a room API, this is a booking API. What does the room API do? It's gonna show, okay, you can add a description. I'm not sure how you do it in Express, but in Java you just like add annotations. You add like a tag annotation, and then from there you're gonna say what this does. So the room API is an API to create a room, and then anybody that runs this API in the future, they can tell that, okay, this is what the get request is doing, this is what the put request is doing, the delete. There are two different get requests. There's a get request that has an ID parameters, then there's a get request without the ID parameters. This one means that you're going to be getting everything. We can also like add descriptions using the add operation annotation. When you add the descriptions, you can say, you see here the put request. The put request says this updates the room details, and then the post request tells you that this creates a room. So you can do this. You don't need to write like a lot of code or anything. You just add this as a dependency. Then you're gonna add like a small descriptions, and then it has this built-in UI. So if you are building a back end, right, and then you don't want to test your back end on Postman or Insomnia, whatever that you're using to test your back end, you can use Swagger. Then Swagger is gonna do the work from you. You're gonna run this on your browser. Maybe this is running on localhost 8082. So you're gonna say localhost 8082 slash swagger UI slash index.html. Then you're gonna see this whole page, this UI that is built in. Then you can go through. So anybody that can view your code and run your application, they're gonna see this, making their lives easy for them, right? So documentation is key part. And yeah, those README files are also essentials. Consistent structure, clear APIs, predictable error handling, logging standards, and testing. Okay, let me see what time do we have. Uh, okay, we still have a not so much, a lot of time. I want to also have like a Q&A. So, okay, then let's talk about understanding requirements. So, understanding requirements, we've been talking about this. I even gave an example to say some companies hire system analysts for them and like business analysts so that they can understand the requirements and convert the requirements into technical requirements. But let's say there's no analyst, or you're the system analyst in this case. What do? We're gonna use the requirement clarification framework. So you need to know who is the user, who's going to be using this, who's going to be the admin, who's going to be the customer, who's going to be the internal staff. Let's go back to our case study, the food delivery system case study. In the case study, who can be the admin? The admin is now the one that's going to be creating the menu, updating the menu, etc. They can see where the item is. Also, they can see the location. They can see everything. Basically, the admin can be the restaurant manager. I mean, we can give them the admin access. Who is the customer? The customer is going to be the person who's ordering the food and the smartphones. The internal stuff, usually it's moderator in your, maybe you're going to write them as moderator in your backend. So usually in your backend, you're going to have admin, moderator, and user. And then you can say now who's the moderator. It's going to be the internal stuff. The internal stuff are the restaurant staff, and the drivers themselves are the internal staff. They see different things as compared to the admin, as compared to the customers. Okay, cool. What problem are we solving? So, in this example, what problem we're solving, we're trying to deliver food to a customer efficiently without them going to the store and maybe getting in the line, so they can either come and collect or we deliver them the food for them. So this makes them simple that they can now pay online. They don't need to think about like a lot of things, driving to the shop and coming back with the food cold. So we need to think about that to say what problem are you solving and how are you solving this problem. Okay, cool. What are we expecting? What scales are we expecting? Is this like a small restaurant? Is it like a big franchise restaurant? If it's a franchise, if it's a, let's say McDonald's. So this means I must now expect large volumes of users. And how do I handle those large volumes of users? Now we talk about load balancing in this case. Okay, cool. Then as a business needs to understand like what constraints exist. Is it the budget? Does the company not have like the enough budget to build the software that they want? Is it the deadline? Are they giving you like a small time to build this feature? Compliance, existing system, what is there? What constraints are there? There are a lot of existing systems. Obviously, there's like Uber Eats, there's what's this, Mr. D, etc. So there's also like competition. You need to think, how does this make or save money when you're building a software? So now you thinking about these things is what takes you from a software developer to now a industry software developer, person who's an industry expert level developer. And I don't like the term developer most of the time. I like engineering because engineering speaks about you being a creator, you creating, but before creating, you designing, planning and designing, then creating, then after creating, you execute. That's the role of an engineer. So as a software engineer, you need to think about all of these things. Okay, then the part of debugging. Okay, debugging, I did mention it a couple of minutes ago to say when you debug, there's nothing new that you're doing. You just need to understand the state trace and the different HTTP requests. So the steps of debugging is that you need to recognize patterns, right? We'll talk about this, and then okay, reproduce the issue, isolate the layer, inspect log, hypothesis test. So let's say you are now building the menu savers. And the menu savers, you're gonna create a model for the menu, a controller for that. And when you do that, let's say you're trying to run and test this alone, and you get an error. So you need to now isolate it to say, okay, this is where I'm getting the error, just the menu part of things. And from there, where's the error? Excuse me, does the error come when I try to get this request, or does it come when I try to update, or does it come when I try to post? So now you have to now go in detail in debugging, go step by step with it. Don't rush debugging. Whether you can use AI or what, but you don't have to rush. You need to go step by step in order to you now find the problem. Okay, now I've also talked about the part of dealing with clients. So it's a matter of how do you communicate effectively. So oftentimes we'll have to present your application or system to business stakeholders. They don't speak technical terms, but what do they speak? They speak deadlines, they speak budgets, they speak risk, they speak growth, they speak solutions. So your role is going to be to translate tech into business. Okay, let's do this. Okay, so yeah, this is about it. We have about 30 minutes left. So in this 30 minutes, I'm just gonna wrap things up. In wrapping things up, I'm gonna talk about the things that this checklist, the things that I didn't touch about here. But before that, let me just check the chats. Okay, there's no questions, there's nothing as yet. Okay, let me go back. Okay, let me do a full screen. Okay, reality check. Okay, so I did talk about the code structure, the documentation, following the best practice. We didn't talk about the environmental variables, but I think you know the .env file. I'm gonna talk briefly about that. So there's also uh, logging and error handling. So what logging is sure how to explain it. So logging and error handling is basically now once you've built your system with its URL. So maybe you can use what's this thing called agitator to monitor. So there are monitor logs to check is everything fine? Is the database connected? But again, you have to add dependencies for that. Um, Not sure what dependency it is on your Express, but I think it's architecture. No, I mean, what's this agitator? So you add this dependencies that can do monitor um, your system. So what it does, let's say you start up your application. When you start up your application, you run npm run dev or you run npm start. So before you do that, it checks to say, is your database connected? If maybe you're using PostgreSQL, is it on? Is it also running as you're running the application? Because you can't run your application if your application is dependent on a database or it's using a database. Obviously, you need to have the database also running in your local development. So the monitor logs are essential for that, and also there is health checks. Let me actually do this. Mm, Let me do this. Let me go to my IntelliJ to just show you a brief example of this. And then I'm also going to show you an example of GitHub to say how does Git work. And Git is also a important part of software engineering in a sense that when you build your code, it doesn't stay in your local development. When you build your code, you can push it um, into now into a branch maybe you share with other people in your team. You also use GitHub when you deploy your code. Let's say you're going to be deploying your code to what's this render. In order for you to deploy your code, you are going to be using GitHub. It's going to be taking your code from GitHub. So understanding GitHub and the GitHub basics is also essential. So let me find a system. Let's go to the hotel management system. This window. Okay, I want to run the application and show you number one, the code structure, right? So in understanding and building, if somebody was to take this code today and run it from scratch or update it, they see that there's clear naming of services. They assume that, okay, when I go here, this is an API gateway. When I go here, this is an auth service. So I'm expecting things that are relating to authentication, your JWT, your security config, etc. This is a food order service. Okay, there are two food services. Then there's room booking service. So they are expecting to see okay, I can't run this. So they're expecting to now see things that are pertaining to the food service in this folder. They're expecting to see the models. They're expecting to see what's this? Controllers that are pertaining to how they order their food. So this follows like a clear structure. So you see here that I have my controller, I have my config, my client, my DTO, entity, the filter, etc. So this makes things simpler to anyone that's going to be viewing the application. So what I wanted to show you is, let me run this out, see if it's fine. I want to show you how the monitor logs work and how you can log and see if everything is working perfectly fine in your application. Okay, so it's still building. Okay, 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 cool. So I'm not sure if VS Code does have this, but even if it doesn't, but you must be able to see the health of your application by monitoring like the endpoint, the get request, the post request, is everything okay? You have the mappings here, which is also going to check if everything is okay. Okay, for the sake of time, I'm not going to wait for this to load. I just wanted to show you like this part of how you monitor the health, and you're gonna need to just add a dependency for that. Okay, yes, here it is. So you see here, it shows me that, okay, in my application, it is connecting to the database. What database is it connected to? It's connected to the H2 console. Okay, cool. Discovery Composite, what is it using? It's using Rega Discovery Client. Is also that working? So this is what this health monitoring does. So we just need to just add dependencies for that. Right. Then in terms of like mapping here, you check the get request. Is my get request okay? What do they do? Um, and yeah, that's basically the life cycle of software development. So you build things, you monitor them, and their health. Is it the database running? Is it connecting to the database when you start the application, etc. Okay, then there's error handling, which is also a technical part. When you build a controller, you need to build now a error handler for that. So say, if now I am trying to access this part, if I'm trying to make a post request, what errors are in place? So you know that try or catch system, you need to implement that. Okay, cool. Now let's move on. Let me close this, save up my resources. Okay, yes, exit. Okay, we have about 20 minutes left. Okay, so again, this is like the business side of full stack. If a CEO or a client asks, how does this feature make us money? Can you answer? Okay, and still on the business side of full stack, you need to understand that how your application performs, that's equal to the business's revenue. Downtime means loss, security breach means reputation damage, scalability means growth readiness. So, I believe that I've explained all of those things in detail, the business side of full stack. These things are all like part of understanding real world systems and how they work. And in terms of performance, I think I saw a message here. Let me do this. I think I saw a message in the chat. Somebody said, going to break my fasting. Okay. I'm not sure. Uh, okay, I'm not sure if this was part of it when they're saying like performance. How does your application perform effectively? So, in order for your application to perform effectively, you need to think about a lot of things that you're learning right now. Currently, you are learning data structures and algorithms. So, you're not just learning this for the sake of learning, you need to apply them somewhere, somehow. If you are given like a situation that has maybe like data, what do you store this in? Do you store this data in an array or list, or do you store it in a dictionary? Do you store it in a set, etc.? So you need to think about the data structures and algorithms in this sense to say, okay, cool, I've stored this in an array. I want to search this. I want to search this. Is it searching easier in an array than it is in a dictionary? You need to think about now your big O notation. So performance is all about like applying all the things that you're learning here and now practice. And when I say the things that you're learning, I'm not just talking about now the data structures and algorithms, but I'm just talking about everything. The clean code practices, the naming conventions, everything. You need to apply it here effectively. Okay. All right. So now I'm gonna open up um, the chat. Now I'm gonna be now viewing the chat for a Q&A to say what do you want to ask me. You wanna ask me about the most industry mistakes we make, or imposter syndrome, or how do you start freelancing, We want to ask about architectural decisions. How do you choose what languages to use? How do you choose if you want to follow a monolithic architecture or microservices architecture? How do you build a portfolio? How many of you right now have a portfolio? If someone was to now ask you to say, okay, you're a software developer, do you have a portfolio? What projects have you built? Do you have a portfolio? And if you don't, do you know how to build one? So now I'm opening the poll to say you can now ask me questions. I've been the one that's talking and leading the session. So please bring your questions to me. Okay. Julius, Steve, Emmanuel. I'm not sure where the Tabiso go, but can you tell me, or rather, can you ask me any question that you currently have? And if there are no questions, please do indicate in the chat. Okay, I'm gonna assume that there aren't any questions. Okay, no questions from my side. Okay, Steve has been silent from the beginning to the end of the session. Emmanuel, not sure if you just joined now or you've been joining and leaving. Do you also have questions or you don't have any questions? Okay. And if you all don't have questions, I'd just like to say thank you for today. It was very nice having this session with you. And I'm not sure if, okay, but there's a recording for those that weren't able to attend. And for those of you that, I think, Emmanuel, you were here briefly and you also left. There's also going to be okay, Emmanuel has left again. Wow. Okay. Okay, thank you so much, Julius. And Marianne, thank you so much also for today. Then we can wrap it up.